This is Algebra 1, Term 6, Lesson 5, Data Everywhere. We'll begin with a project called Dear Data, and then we'll move on to a Desmos activity, and we'll finish with a short task in GeoGebra. So let's start with Dear Data. Dear Data was a year-long drawing project by two ladies who lived on opposite sides of the Atlantic Ocean. They have actually collected all of their data in postcards, and they have created a 300-page book with their artwork. It's incredibly interesting, and one thing I love about this project is it will pull in students who typically are not as keen on doing mathematics but may be really excited about this project. And so what they would do is they would come up with some means of recording data that was artistic in nature. So they would create their own little codes, and then they would record what they were doing, some artwork or some kind of graphic to show what they were doing. The very first one that they sent is this one. This was a week of clocks for, well, it wasn't Georgia, it was actually Stephanie that did this. And so every time she used her phone, she used one of these little symbols, and every time she used her laptop clock, and then if she used her tablet clock, and then her husband's phone clock, and then her watch, and then her car. And so she's got all these different sources where she has clocks, and she put a number next to each of these symbols for the number of times that she did look at a clock, and then she'd put that number of symbols in her graphic. So you notice she has 151 off of her phone, but she only had one time that she looked at the microwave, and she looked at the church clock one time, and so on. So anyway, that's her graphic. And then over here she has these, I don't know, it looks sort of like kind of code that she used, and she gave the symbols that are in her code. They recorded this data on postcards and sent them to each other, and then each week they would choose another thing to record. So here's a different week. This is week 7, and they were complaining. So a week of complaints, and so they logged all their complaints and the different types of complaints, and then they recorded them. So she did hers with color, and she did hers with musical notes, and it was very interesting. And this one was week number 24. They had a week of doors, so doors that they went through, either physically or some other type of door. So here it was the building where they work, maybe the cafe, a pub, or a restaurant, a client's space, getting in and out of transportation like elevators and taxis and so forth. Very, very interesting data. So anyway, they collected this for 52 weeks, and it became like a ritual, and they would spend the week noticing and noting their activities before they translated it into some kind of hand-drawn visualization. Now on the slide, I've given a copy of the video, so you may or may not be able to, or your kids may or may not be able to watch that depending on the settings for your school district. Some school districts don't allow students to view YouTube videos. So if that's true, I would recommend showing this to the whole class so they can watch the story about these two women and how they collected their data and the artwork that they did. You can also, if your district allows it, give them access to the website that has the more detailed. If your district allows it, you could actually give your students access to the website that has this video and the other information about the project. And this is really just for inspiration. So we're hoping to give kids an opportunity to see different ways data can be represented in a way that's a little outside the box, a little different. We're used to spreadsheets and graphs and tables and very structured things, but these are very artistic representations. So the two things they'll type on this slide after watching the video: something that they noticed, they thought was interesting, and one thing they wondered while watching the video. I know one thing I wondered is, did these women have a background in art? Because their work is absolutely gorgeous, as you will see. Okay, once they finish the video and they've looked over the data, and you can hand out, you can give them printouts. If you look at the link I've given you to UCube, they have a full series of activities, not just this one, that are related to this data collection project. So feel free to use any or all of that. If you have time, you could do like a couple of weeks long project for the whole class and let them really just get into this. This is fun. It's a great end of year project. It's a good way to kind of wrap up the year, and it's also a real good culminating activity for the portfolio. Students can put the information that they gather and what they learn about themselves and their team in their portfolio. So here is what they're going to do as a team. They're going to brainstorm something they can collect, some data they can collect every day for the remaining days of school. So the way that I've scheduled the course, if you've remained anywhere near the pace that I've suggested, I've given you really an extra week or two of nothing at the end so that you can do with it what you want. So what I was hoping is that you would have enough time left over to spend time collecting data, doing artwork, doing visualizations, doing presentations. Students could present their data projects to the class, and students could also present their portfolios to the class. So this would be a time to kind of summarize the whole year of learning, and this data gathering would be part of that. Here it says they can use some of the ideas that were in the video, or they can come up with ideas of their own. So maybe they like that clock idea. How many times did you look at the clock? That would be interesting. Or how many doors did you go through this week? The sky is the limit when it comes to this activity. Give kids opportunity to be as creative and different and unique as possible. If you want to make this really good, what I used to do anytime I gave a project like this where kids were having to come up with a way to collect something that's new and original, is I would have them submit their idea, and then no other team would be allowed to use their idea once they submitted it. So that therefore you're not getting like, the whole class doing one or two different things. It would be a whole bunch of different types of data collection. And you could even make it not just one class, but maybe all of your classes. So if I had teams in every class doing this, they'd all be, racing to get their ideas submitted so that they could have their first choice in the types of data that they're collecting. That's the strategy that I use to keep them from all doing the same types of projects and making it a lot more interesting for the students and for me and for others who are viewing their presentations. You can also discuss strategies for presenting the data. So they did artwork on postcards, they could do posters, they could do something on the whiteboards, they could create videos, they could create music. The more creativity they put in here, the better. Now on the slide, I've given them a list of things here in their notes. The first big thing it says here is be creative and be original. So you want to have a project that's unlike anyone else's. You need to first decide as a team what data will be collected, and that's the one I would have them submit to me as a teacher so that we could have every team collecting different data. And the second thing is, how are you going to collect the data? They could create something common, maybe a form or sheets. They could do it on paper. To let them come up with some ideas. I will tell you, once you get a good group in there, it only takes one class doing this well to really help this take off with other classes, because they do tend to get a little competitive. They'll see somebody's fantastic presentation and they'll want to do the same. Be sure to put that stuff out there for the whole world to see if possible, so that future classes will get a glimpse of the type of activities that they can do in mathematics. So next we're going to go to Desmo's classroom and look at qualitative versus quantitative variables in data. And so here we have a total of 15 screens, and in the first screen they're just taking a quick survey. What is your favorite type of music? Now they may say their type is not listed, and in this day and age that's pretty common. We'll just tell them, please pick one that's closest to the one you like best, if there's not one here that's exactly what you want. And then on phone notices, this is on screen 2. Most schools have some restriction on phones in class, so we don't want to encourage them to get their phones out. But what we do want them to do is give an estimate for the number of notices that were on their phone when they first unlocked it this morning. So let's say they woke up and grabbed their phone and unlocked it. How many notices were sitting there? Now if they don't remember, Tell them to just estimate. This is something they probably do every morning. So most kids have some idea of about the number of notices they might receive. And for students who don't have a phone, and I always had a few because their parents wouldn't allow it, they should type 0 because they didn't have a phone, they wouldn't have any notices. All right, here we're going into some terminology, some definitions. When we collect data, we collect from individuals. Individuals can be people, they can be animals, they can be objects and things. An individual is called a data unit. And variables are things that vary or change. And if we were to ask 10 individual people about their music that they enjoy, just like we did earlier on screen number 1, the answers would vary. For the individual students in the class, the variables for the students could be sports that they play or their favorite class. For if the individuals were penguins, like the ones in the picture, your variables could be their gender, their location, their weight. For individuals like colleges or universities, the variables could be the number of students in the college, the age of the college, how long has it been around, and location, where is it located. Next, they're going to determine a group of individuals that they belong to and one variable that can be used to describe their group. So maybe they could play an instrument, and they can reword that, by the way. So I am might not be the best wording. I belong to, they could say it like that. But maybe they're a part of a team. Maybe they have a particular skill, like they like to paint. They could even put their family name. I'm a member of this family, and one variable for my group is, and they could list some things that you could ask their family if you were going to give them a survey. So what are the individuals? So here we have an example of Arby's restaurant chain, and they have sandwiches, and the types of meat in their sandwiches, the number of calories, and the serving size and ounces are different things we would need to know. That's some data associated with Arby's restaurants. So which are the individuals in this context? If they're not sure, they can go back. These are self-checking, so they will let them know when they get the right answer. Next, same Arby's restaurant, but this time, what are the variables? Okay, now we're going to look at two different types of data, categorical and quantitative. Now, categorical is qualitative, so we kind of use those words interchangeable, but in algebra, categorical is what we use in our standard for this course. So quantitative are things you can count, they're things you can measure. Qualitative are things you cannot measure, but you can describe using words or ideas. So favorite types of music, would that be categorical or quantitative? Is number of notifications categorical or quantitative? And then what about categories? What are categorical variables? Here are 3 examples of individuals, students, ice cream, and automobiles. For students, we could have the categories elementary, middle, and high school. And for ice cream, we could have vanilla, chocolate, and strawberry. And for automobiles, we could have cars, trucks, and SUVs. Those are categories of automobiles. Now, they're to give another example of individuals with categorical variables for you or your peers. Okay, when we gather quantitative data, we measure, we count. The distinct numerical values that we are using to describe quantitative data are called quantitative variables. So here's 3 examples. For students, you could ask their age in years. That's something you measure or count. Ice cream would be number of calories. The automobiles, you could use gas mileage. And so in the box, they're going to give another example of a quantitative variable that can be used to describe you or your peers. On this one, they're going to sort into 2 groups, categorical, which is qualitative, and quantitative. And they have 2 groups of 5. When they get to the next screen, it will give them their results. If they're not right, it'll say this. And as soon as it is, this message will change to let them know. On this screen, we're back to the Arby's example, and students are asked which variable is categorical. On the next screen, we're asked which variables are quantitative. Remember back to the music question at the beginning of class, which of these statements are true about that data? So they're talking about the definitions of terms that we've used in this lesson, individuals, variables, and whether the variables are quantitative or categorical. and then the phone data. So we're going back to those questions at the very beginning of the activity, and we're kind of summing up the new terminology. The last task in this assignment is to go to GeoGebra and do a quick self-quiz over qualitative versus quantitative data. They will click the link to go to the site and then look at 6 problems. Number 1 is the problem, and this is the data from this site, and it tells you what it's about. They're going to list all the columns representing quantitative variables, and then the columns representing qualitative variables, and then all the columns representing designators, which is the same as individual. They will click here to see the answers once they've decided which is which, and then they'll go to the next problem, number 2, and do it again. Which columns are quantitative, which are qualitative, what are the designators or individuals. Keep doing that, and they go all the way to number 6. Now once they're done, they're going to go back to their slides, and they're going to choose one of the problems and paste a screenshot on this slide. So they can choose any one of the 6, and then they will explain their answers to their question for their chosen problem by typing here. If they don't have enough space, they can shrink it down. They can insert another text box, however they want to do it to answer the questions. So the last slide, they're going to create their own set of data that is similar to the 6 problems they saw in GeoGebra. They will need at least 1 column for their individuals, 1 column for their qualitative data, and 1 column for their quantitative data. They can have more than 1 column for any one of those, and they will explain which column is which and why each column is what it is. Now in their show notes, I'm giving them some instructions. They can create their table in Sheets and insert a picture of their data, or they can create a table here in Slides using the tools in the toolbar above. They can also collect their own data, but if they do decide to use existing data from another source, they should give reference to that data. They need to cite their sources that they used on the slide. They can do exactly what GeoGebra did and just include a link on the slide to the data that they cited. And this concludes our Data Everywhere assignment. We only have 2 more lessons this year, and then we'll take our final exam. Y'all have a great day.